Let's do problem 9 on page 219 of chapter 8. And let's read the problem. Number 9. Oh, let's zoom in a little bit. Okay, come on. It's like without my glasses. Okay, it says calculate the angular velocity of the Earth in its orbit around the Sun. That's part A. And B, about its axis of rotation. So I've already kind of set it up here. So for part A, we want the angular velocity. Oh, that's right. I forgot to zoom back out. Thank you. So here's what's given. We have the Sun and the Earth, and it's zipping around. And then here's the Earth going around its axis. And what we want to find is the angular velocity of these things. And so, and it's not that difficult to do. If you just realize like that the Earth sweeps out, it goes around its, once a year. So it goes through, for part A, it goes through 2 pi radians in 1 year. Well, we'd like them in radians per second, so all you have to do is say, well, 1 year is 365 days. 1 day is 24 hours. And 1 hour is 3,600 seconds. And we've got to plug all that in to my calculator. 2 times pi divided by 365. Take that and divide it by 24. And take that and divide it by 3,600. And then let's put it in scientific notation. And you get 1.99. So omega is equal to 1.99 times 10 to the negative 7 radians per second. So this is how many radians it sweeps out every. Now think about it. It takes a whole year to go around the Sun. So we're not sweeping out a great big angle every second. There are planets that do, that circle really close to their stars. It's a matter of days rather than a whole year. But now for part B, here's the Earth, and it's going to go around its axis. Well, it goes through 2 pi. Right, it goes, now I'm just going to call it 24 hours. Whoops. Technically, that's not correct. It's actually, the sidereal day is actually 23 hours, 56 minutes, so many seconds. And if you got really, anybody do that, if you remember that, that's pretty cool. That's pretty cool. So your answer is going to be a little bit more accurate than mine. But I mean, I'm just going to round it off to 2 or 3 significant figures. So this is good enough. So I'm just going to take this and say that 1 hour is 3,600 seconds. So 2 times pi equals, and then divide that by 24, and then divide that by 3,600, and you get 7.27 times 10 to the negative 5 radians per second. That's now this is, think about it, this is almost 100 times faster Well, more than 100 times faster. It's probably 365 times faster. I better, yeah, okay. But in any case, now, Tyler, what'd you get when you used the sidereal day?
I actually just rounded it off to 7 times 2.
Oh, okay. Yeah. Yeah. But anyway, so it's that simple. Just, if you know it's going to make a certain rotation, that's gone 2 pi radians, and then you do that. Any questions on this problem? Okay. Well, that is...
Oh.
That's good.